Welcome to today's explainer. So, we're going to be decoding a regulatory framework that literally started in the stars. Seriously, we're looking at how a system originally designed to keep astronauts safe in the literal vacuum of space ended up completely revolutionizing modern food safety right here on Earth. Just imagine, for a second, a single rogue crumb floating into a multi-million-dollar control panel, or even worse, a bacterial outbreak when you're millions of miles away from the nearest hospital. No way, right? It's just a totally fascinating journey of engineering, biology, and super strict risk management, and we're going to break the whole shebang down for you today. All right, here is our quick roadmap for today's explainer. 1. The origins of food safety. 2. Defining the HACCP system. 3. The power of prevention. 4. Advantages and highlights. And finally, 5. Building your HACCP plan. Let's just dive right in, shall we?
Okay, I want you to picture this. It's the early 1960s. The U.S. space program is really pushing boundaries, but they're facing this highly practical and potentially deadly problem. How do you guarantee with absolutely 100% certainty that food won't make an astronaut sick in space? Because, let's be real, a foodborne illness in zero gravity, that is a catastrophic risk. Just testing the end product, checking a few random samples from a batch, that just wasn't going to cut it anymore. NASA demanded absolute perfection. They needed a system that basically offered total assurance against any bacterial, viral, chemical, or physical hazards.
So that brings us to Section 1, Origins of Food Safety, from TQM to the stars. It's actually really fascinating to see how two massive historical leaps kind of converged here. Back in the 1950s, Dr. W.E. Deming developed Total Quality Management, or TQM frameworks. The goal was to improve quality while driving down expenses, and it heavily influenced Japanese manufacturing at the time. Then, the second major leap happened in the 60s. That's when the Pillsbury Company, teaming up with NASA and U.S. military labs, took those proactive concepts and applied them directly to food. They created the Hazard Analysis and Critical Control Point System, or HACCP, specifically for the space program. And guys, this was so incredibly effective that by 1974, the FDA actually adopted HACCP standards for low-acid canned foods. Fast forward a bit to 1985, and the National Academy of Science was widely recommending its use to ensure food safety everywhere, not just up in orbit. Moving right along to Section 2, Defining the HACCP system and decoding the language. So HACCP stands for Hazard Analysis and Critical Control Point. At its absolute core, it is a prevention-based food safety system. It's designed to assess the inherent risks in a product or a process, and then figure out the exact necessary steps to control those risks. It completely shifts an operation away from just, checking a finished product at the very end. Instead, it controls the procedure as far upstream as possible. The whole goal here is to stop the problem before it even happens, rather than just trying to catch it after the fact. Now, to make all of this actually work, we really need to define a few key terms. First up is a hazard. In this system, a hazard is very specifically defined as a biological, chemical, or physical property that might cause an unacceptable consumer health risk. We're talking about things like dangerous E. coli bacteria, maybe accidental splashes of industrial bleach, or, and this is wild, even a literal shard of metal from a broken machine somehow making its way into your food. Definitely stuff you want to avoid. Right, so once you know your hazards, you've got to find your critical control points, or CCPs for short. A critical control point is a specific point in the food system where a loss of control could result in that unacceptable health risk we just talked about. It is the exact juncture in the process that simply must go right to ensure safety. Think of it like a specific cooking temperature step, or maybe a final pass through a metal detector. It's the absolute make or break moment. So the crucial piece of the puzzle is knowing exactly how to measure safety at those CCPs. And that is where the critical limit comes into play. This is the absolute maximum or minimum value to which a physical, biological, or chemical parameter has to be controlled at a CCP to keep that risk in check. For example, if you're cooking chicken, it has to hit 165 degrees Fahrenheit to kill off bacteria, right? Well, that specific temperature is your critical limit. It's a firm, scientifically documentable boundary. No guessing allowed here. All right, Section 3, the power of prevention. Reactive versus preventive. This really brilliantly illustrates the downside of the old ways of doing things. Traditional food inspection is heavily resource-intensive, and honestly, it's just reactive. An inspector walks in, looks around, and basically gets a mere snapshot of the conditions at that exact second in time. It doesn't tell them a single thing about what happened yesterday. The HACCP approach, on the other hand, forces continuous self-inspection. Because a facility is constantly documenting its adherence to those critical limits we mentioned, regulatory agencies can review those records and effectively get a look back through time. Now, the one disadvantage here, setting this all up takes massive upfront time and super rigorous documentation compared to the old snapshot method. But the payoff is continuous, reliable safety rather than just hoping for a well-timed inspection. Which brings us to Section 4, Advantages and Highlights, the Universal Application. The highlights of the HACCP system are honestly pretty vast. By emphasizing proactive prevention over just after-the-fact inspection, it systematically addresses all the different types of hazards, microbiological, physical, and chemical. And because it relies on universal scientific principles, it is incredibly adaptable. I mean, you can implement it in a tiny local corner cafe, or you can scale it all the way up to a massive multinational enterprise. In fact, it's so globally recognized these days that it's actually completely mandatory if you want to export certain food sectors to various countries. Plus, it seamlessly integrates right into broader quality assurance plans, like ISO standards. Now, looking at this from a pure business perspective, this management system offers a really clearly defined process-based structure. It totally replaces chaotic troubleshooting with streamlined communication, and naturally, that's going to boost customer and consumer confidence. But perhaps the absolute most pragmatic advantage here is risk management and legal protection. Think about it. By holding on to meticulous records that prove you followed a scientifically sound safety system, a company gains a vital legal defense in the worst-case scenario of an outbreak. It really isn't just about doing the right thing. It's about having the paper trail to prove you did the right thing, day in and day out. And finally, Section 5, Building Your HACCP Plan, Laying the Groundwork. So let's look at how this builds from the ground up. You can't just slap a sophisticated HACCP plan onto a messy operation. A space-age plan will completely fall apart in a dirty kitchen. The production of safe food products absolutely requires a solid foundation of prerequisite programs. Traditionally, this means strict adherence to CGMPs, or good manufacturing practices. We're talking about the basic conditions necessary to protect food, like fundamental facility sanitation. Crucially, it also requires deep, thorough employee education and training. Management has to carve out the time and resources so that employees aren't just blindly following rules, but they actually understand why monitoring a critical control point is so incredibly vital. Okay, once that solid foundation is set, actually developing the plan involves a few preliminary tasks. Step 1, you've got to assemble a multidisciplinary HACCP team. You want engineers, sanitation experts, production staff, and the local personnel who actually know the day-to-day quirks of the kitchen. Once your team of experts is together, the next step is precisely describing the food. You map out its ingredients, the processing methods, and exactly how it's going to be distributed, like is it kept frozen or just at room temperature? Finally, you have to define the intended consumer. Are you serving the general public, or are you serving highly sensitive populations, like maybe infants or the elderly in a hospital? The risks, and therefore the control measures, change drastically based on that information. And keep this in mind, the flow of food from receiving all the way to serving is a highly dynamic process. Once a plan is in place, it is definitely not set in stone. Procedures absolutely must be rechecked and validated whenever there's a change. If you change up a recipe, or if you buy a new piece of cooking equipment, like say you switch from baking to deep frying, or actually even if you just change the preparation quantity from a small test batch to a massive banquet scale, the entire hazard analysis has to be revisited. You have to ensure your critical limits are still doing their job. So, as we wrap up today's explainer, I really want to leave you with this thought. We've traced this incredible path from the extreme demands of zero-gravity spaceflight all the way to the standard operating procedures of modern food service. The HACCP system proves, without a doubt, that safety isn't just a happy accident. It is the direct result of rigorous preventative design. So the next time you're out, take a look at the food systems around you and ask yourself, is your kitchen operating with space-grade safety? Thanks so much for joining me today, and keep exploring the systems that shape our world.